Okay, so we are going to find the MAD, or the mean absolute deviation, of the following data set. So here's our set of data. We've got 27, 30, 37, 16, and 25. Now remember, when we're finding the MAD, or the mean absolute deviation, we need to make sure we're creating some sort of table to help us organize all of our work. So here's the table I've created. My first column here is our original numbers in our data set. And our step one of finding the mean absolute deviation is finding the mean of these original numbers. So we need to add up or find the sum of these 5 numbers. So if we were to take 27 plus 30 plus 37 plus 16 plus 25, we get the sum 135. And we're going to divide that by 5. And the reason we divide by 5 to find the mean is because there are 5 numbers in our data set. So if we do this division, we should end up with the answer 27. So our mean of this first data set is 27. So we're going to fill out our column here with 27s. So we've done step 1. Now step 2 is to find the distance our original number is from our mean that we just calculated. So if we're looking at 27 and 27, there's no distance there since that's the same number. 30 and 27, they are 3 apart. 37 and 27, they are 10 apart. The distance between 16 and 27 is 11, and the distance between 25 and 27 is 2. So our distance step is our step 2. Now step 3 has us finding the mean of our distances. So we need to add up these 5 numbers and then divide by 5. So if we add up 0 plus 3 plus 10 plus 11 plus 2, you get the sum 26. So we need to take that number and divide it by 5 because, again, there are 5 numbers in that data set. So 5 can go into 26 5 times. Here we're going to have a remainder. Now remember, when we have, we should have a remainder of 1. When we have a remainder with our number inside our division house, our dividend, we add a decimal, bring that decimal straight up in our answer, add a 0. And the reason we can add this 0 is because 26 and 26.0 is the same exact value. And by adding that 0, we're able to drop down another number to continue our division. So here 5 can go into 10 2 times, and we've gotten rid of our remainder. We've turned that into a decimal. So the mean absolute deviation of this data set is 5.2, or 5 2/10.